And it's important that you turn your wheel only in the clockwise direction. Do not overshoot it and just back it up. If should you overshoot it, back it way up and then come back up to it. And using my optivisor, I'm going to bring that right into 0 degrees. I got to get right down in there. Camera's in the way. There I'm at 0, and then I lock it each time. Just snug it up, and then it's not going to move. I've already set it for 150 deep, and I'm going to turn the machine on and feed very slowly now, because remember, these cutters are delicate and we are cutting steel, not aluminum. Get a little oil in there, and I'm feeding again. Okay, now I'm cutting with the y-axis, the cross feed on the milling machine. Nice sharp cutter. Let the cutter do its work. And I'm breaking through. Bring it back in. Loosen the lock, and I'm advancing it to 40 degrees. I'm getting my head down in there. Locking the rotary table. .40 degrees, I just double checked it again. Now, of course, I'm not going to show all of these. The video would be too long. So I'll finish this cut. And then I'll see you again when I'm cutting number 9, which will be at 320. I've cut 8 slots, and I'm on the 9th one and the final one. And that'll be at 320. And I've already turned the rotary table to the 320. And let's go with the last one. Again, I'm feeding with the y-axis. The x-axis is still locked at 0, 0, 0. There'll be all kinds of burrs on here when we're done. Okay, we're done with 9 3/16 wide slots. Just as a side note here, in Illinois every fall and then again back in the spring we are plagued with these tiny little beetles. They're not really a ladybug, but they kind of look like them. And they just come in the dye, it seems like, after they've annoyed you. But here's one here that was crawling around a minute ago, and just to set an example for the other beetles, if they're watching, you know, this is what I'm going to do to you. Alright, so much for that. Now, at this point, all of these slots are strictly straight slots, 3/16 wide. They are not tapered. Now, we need them to be tapered. So, I have already changed collets and bits. I have an 1/8 inch bit in there, and I've changed the speed to 1750. So what I'll do right now is, again, I'm going to bring that down just until it touches the bottom of the slot, so it'll be the same depth as the other ones. and I'm locking the quill and backing it out. The next thing I need to do in order to make the slots tapered, remember they're not tapered yet at this point, is we have to mill each side of them at an angle. That's why I changed to an 1/8 inch bit, because it would interfere with the other side if we didn't use a smaller bit. So it's an 1/8 inch bit. Now what I'm going to do is cut all the slots again, but not at 0, 40, 80 and so on. Those are the angles that we already cut. Since they are 20-degree angles, we need to go 10 degrees on each side. So now I'm going to do what you see in the red here. 10, 50, 90 and so on all the way down. That being done, I will mill the other side using what you see here in blue ink. I'm not sure that shows up, but this is black, red and blue. But we're going to do the red right now. So looking at the protractor, I'm going to move it to exactly 10 and lock it like that. But that's still not going to do it. I need to move the table in the X and Y or Y. Let me restate that. I need to move the table in the X direction, either in the positive or the negative, in order to do that. So let me do that and then try to explain why I'm doing it and how I arrived at that number, but it'll be 60 thousandths. Now looking at the digital readout, I've moved it 60 thousandths in the negative, and I'm going to do all of the red ones in that position. So I'll go all the way around with negative 60, starting with the 10 degrees. Now as far as the Y is concerned, I did zero that just to illustrate, but that's my actual feeding is going to be done with the Y, again the same as it was before, and I'm already down to the depth of cut. And since this is a very small bit, I'm going to feed very lightly, and it'll be a rather shallow cut as I start, but it'll get deeper as I come to the outside of the work because I'm cutting it at an angle. Now, is that clear as mud? Notice that I'm back on my black arrow. It's set at 10 degrees. See if we can get a little oil in there. And I'm going to feed ever so slowly. I am conventional milling at the moment. When I complete the cut and come back, I will be climb milling, which will clean it up and improve the finish. Now have patience, both as you're watching this video and as you make the cut, if you are inclined to do as such, so you don't break that little bit. And I'm just about out. You see the burr roll over. Now as I feed back in toward the center, I am climb milling. That'll clean it up. I'm making a big point of that climb milling now because I'm going to do just the opposite when I do the blue numbers. For the second slot, I'm turning it to 50 degrees. Locking it. And so on, and I'll meet you at the 9th car. I'm now in slot number 9, and that's 330 degrees. Trying to bring it back into focus. Now I'm ready to mill the other side of the slots, but I'm going to change it from a negative 60 thousandths to a positive 60 thousandths. I went too far. Right there. I'll lock the table. And now I'm ready to mill the other side of the slot, and it'll be the blue ones on the far right. So I'll start with 350 degrees. Never mind that decimal point there. It's 350 degrees, and I'm already set on that. Lock this, and I'm ready to go, and then I'll finally have one tooth that is complete. In review now, I'm back to slot 1 where the black mark is, and again 350 degrees in the blue. Now notice that I am now on the outside and I'm going to feed in. So I will be conventional milling as I feed in, and then when I back it out to where I am now, I will take a cleanup cut, which will of course be climb milling. So it's just the opposite what I did on the other side. So now remember, this is positive 60 degrees. And how did I find that 60 degrees? Initially by trial and error, but it wasn't a mathematical formulation, but I'm sure some of you can figure that out. But I'm just going to say it was baguette bagache. Feed out, I am climb milling. Now since this is repetition, I will do the next 7 off camera, and then I'll finish up with the very last pass on camera. Now here it is, the very final pass, slot number 9, or cog number 9, and that's at 310 degrees, 310. Here we go. That's it. Let's see what we got. You know, a fellow's always hesitant to take it out, but my gauge is fitting in there just right. And the crank itself, although that's not a true determiner, And I want just a little play in there. I don't want it too tight. Well, now let's take it out and give it the acid test. A lot of burrs, but let's see what happens here. Yeah, got a lot of chips in the hole. Too many chips in the hole. Let me clean that out. That's better. I blew it out. I still have a lot of deburring to do. Now she goes right in. Okay, got a little more work to do. Got to turn this end down and make the shank, but the milling is done, and I might add successful. I've done just a little bit of deburring, actually quite a bit of deburring, as much as it's going to get, and double checking it for a fit here, and it spins just fine there. That hole probably could be a little bit larger, but as you can see, it fits into every slot, and you want just a little bit of play so you don't have to fight it. Matter of fact, I probably could have had a little bit more than that. Now it's ready for the rest of the lathe work and the shank. And now it's mounted in the chuck, so I can turn down the end right here to 1 inch in diameter, or approximately. And I've got a stop set as far as the length is concerned. It's about done. I even took a little emery cloth to it, which I usually don't like to do. And now with the end of this turned down, that'll fit in there, and I'll drill an 1/8 inch hole off camera and drive this roll pin in there. I'm hesitant to use anything larger than an 1/8 inch because of the diameter of the turned down end here, so that'll hold. But if you think it needs a larger pin, use a larger pin, or I could use a solid pin rather than a hardened hollow drive pin. There we go. Ready for some action. Now this turned out to be a piece of tool steel. Pretty tough turning and pretty tough drilling. This is just mild steel. I suspect 1018, but I'm not sure what it is, just something I had in stock. Alright, I'm finally finished now, and that of course is the first test piece that I made, and the one with the red on it is the first prototype, and it really is no different at all from the finished one here. And looking at it again, using my 20-degree gauge, I think you can see what we got here. We got 20 degrees both on the female and on the male, and it's 40 degrees between each one, 20 degrees here, but 40 degrees between this one and this one. And that's it. And here we go. Old Tubalcain's going to give it a try. Shall I throw this away? No, I think not. But I am going to use 110 volt instead of the foolish battery drill. And that's it. Hope you enjoyed this little foray into the geometry of a rather irregular shape. Some of you might try this, but for most of you I think it was just the pure pleasure of watching somebody make something that is a little more difficult than what I usually do. This is Tubalcain saying so long for now.